Which of the following statements supports the delocalized model for benzene rather than the Kekulé model for benzene? So let's draw out the delocalized model and the Kekulé model, and then we can see which of these statements is correct overall. So our delocalized model of benzene is where we have our 6-carbon ring and the electrons are in a pi delocalized system, which we represent as a circle inside the ring. Whereas the Kekulé model is where we have 3 pi double bonds, and we sometimes show this as being alternating as well, like so. So let's have a look at these statements and see which of these are correct. So the first statement is that benzene is less reactive than cyclohexene overall. So we know that with our reactions of benzene compared to cyclohexene, benzene reacts via electrophilic substitution and requires a halogen carrier. For example, the reaction of benzene with bromine requires a halogen carrier, such as aluminium tribromide. And that's because the benzene is not electron dense enough to induce a dipole into the bromine. Whereas with cyclohexene, which has this structure here, this is an alkene, and this will decolorize bromine water because it reacts with the bromine directly via an electrophilic addition mechanism and does not require any catalyst or halogen carrier. Therefore, yes, benzene is less reactive than cyclohexene. So let's look at statement number 2. A benzene molecule has a planar hexagonal structure. Now, whilst this statement is correct, this doesn't support the delocalized model for benzene rather than the Kekulé model, because both of these have got planar hexagonal structures overall. So therefore, whilst this statement is true, it doesn't support the delocalized model for benzene rather than the Kekulé model. So let's have a look at the last statement. The enthalpy change of hydrogenation of benzene is more exothermic than predicted from the Kekulé structure. So this statement is actually incorrect. The enthalpy change of hydrogenation of benzene is less exothermic than predicted from the Kekulé structure. So the Kekulé structure, we would expect our enthalpy change of hydrogenation to be roughly 3 times that of the cyclohexene due to those 3 different pi bonds. However, it is much less exothermic than that overall. So this statement is incorrect and does not support our answer. So the only statement which is correct is number 1. Benzene is less reactive than cyclohexene, and this supports our delocalized model as opposed to our Kekulé model, where we would expect the reaction to be similar to that cyclohexene. Therefore, our answer is going to be D, only 1.